Hello, you are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwan. Today's section, we want to look at an important structure which formed in the third week of intrauterine life, and that's the notochord, which formed, of course, the axial mesoderm. And so, without much ado, let's briefly look at this. So, this notochord is a flexible, rod-shaped, structure that we find in, the embryos of what we call chordates, yes. Now, there's this kind of controversy regarding it, yes. They say it's derived from mesoderm. No, its point of origin is not actually coming from mesoderm because it's having an ectodermal origin. I'll show you that. But it's, of course, moving in the mesoderm, forming the axial mesoderm. And this notochord forms the basis of the axial skeleton, very important. And one important function, although we look at the functions, what happens is that it, converts the immediately overlying ectoderm, okay, into what we call neuroectoderm, which will eventually be converted to become the neural plate, neural groove, and of course, becoming, of course, the, neural force, becoming, of course, the neural tube. So we look at that one, in the neurulation. Yes, we look at that one. So that is, of course, the notochord. Okay, so let me actually show you this. So we said that this is the embryonic disc, and we saw that this, with the presence of the procaudal plate, it tells us that this is the cranial end, and then, of course, with the cloacal membrane, there's the caudal end of the embryo. And then we said that there will be a streak coming from the epiblast cells. Okay, that's the primitive streak going through the primitive groove. Then, of course, in the cranial end of the streak, there's this nodular mass over here, which we call the primitive knot, or of course the Hansen's node, which will of course bear a pit. Now, emerging from this primitive knot, okay, or the Hansen's node, will be this, notochord, forming the axial, mesoderm. Because this, notochord, once it comes from the primitive knot, and of course we know primitive knot is coming from the streak, and of course the streak is, coming from the cells of the epiblast. Therefore, it's ectodermal in origin, and therefore, yes, this notochord will be moving in, of course, the mesoderm. So that is what we actually see. So, having seen this kind of notochord, then what is the fate of this notochord? So importantly, yes, one of them that we saw that it's able to stimulate, okay, the overlying ectoderm to become, of course, the neuroectoderm. Now, one thing that you should know about this is that now in between two vertebrae will be an intervertebral disc. Now, this intervertebral disc is made up of two components, the nucleus pulposus and, of course, annulus fibrosus of the intervertebral disc. Now, get to know that the nucleus pulposus will be coming from remnants of this notochord. Okay, the annulus fibrosus, yes, may be coming from, of course, the mesoderm, because, of course, connective tissue coming from, mesoderm of the surrounding notochord. But the one where it's actually coming from the remnants of the notochord is what we call the nucleus pulposus. This portion, nucleus pulposus of what we call the intervertebral disc. The outer one forming that ring over here is what we call the annulus fibrosus. It will be coming from the surrounding connective tissue of what we call the the notochord. Now there's another thing which, of course, we see. But one thing that we find over here is that sometimes remnants of this notochord may lead to something we call chordomas. Okay, that chordomas, like some kind of tumor, okay, over the chordomas. Usually we tend to see it around the area, we see the base of the skull, or of course the cranium, and then of course the nasopharynx. That's where usually the chordomas are seen, because we said that this notochord, we find them in chordates, so chordomas. So that's what we see. But one other structure which is not shown over here, which will come from this notochord, remnant of the notochord, is something we call apical ligament of Dens. So on the second cervical vertebrae, where is the axis, we have what we call Dens, or the odontoid process. Now there's a ligament above it over there that we call apical ligament of what we call Dens. Then apart from that, we also even have Membranous Tectoria. Okay, so Membranous Tectoria, we look at all those ones. We look at the head and neck proper. We look at all these ones. Now this Membranous Tectoria is actually an extension of what we call the posterior longitudinal ligament, okay, which of course we find it in the atlanto-occipital region. So these represent the things that we come from remnants of the notochord. So the remnants, we have nucleus pulposus of intervertebral disc. Then we also find what we call the apical ligament of Dens, and then of course we get what we call the Membranous Tectoria. So these are the three main structures which arise from remnants of this notochord. So already we've seen the main function of this notochord, that is forming the basis of the axial skeleton. Then it's also able to induce the overlying ectoderm, converting it to become neuroectoderm, eventually becoming the neural plate. Okay, and this neural plate will become of course the neural tube and all that. We will look at that. Then therefore tells us that this notochord is an important primordium, helping us to form the central nervous, because it's able to secrete some factors to influence the notochord, to influence of course the neural the overlying ectoderm, converting it to become neuroectoderm, and for that matter neural plate. So therefore we say that this notochord is the organizer of the nervous system, no doubt about that. So having seen this, now there's another thing that we have to clear over here, the distinction between notochord and the vertebral column. So notochord is different from a vertebral column for the following reasons: that it is made of cartilages, while of course the vertebral column is made of bones mainly, although there will be some cartilages in there, but mainly for notochord we have cartilages. Then the orientation, where it is found, this notochord forms between the dorsal nerve cord, okay, like the spinal cord, and of course the gut. So that's where we tend to find it, while of course the vertebral column will surround of course the nerve cord. So that's what we see. And then this notochord occurs in all chordates, yes, during the embryonic stage, and in adult lower chordates, yes, but of course in vertebral column you find them in only higher chordates, okay, but the lower chordates we tend to find only notochord persistent. Then one thing that we find, yes, we've already said that notochord is cartilaginous, skeletal rod, because of course we know that cartilage is also part of the skeletal tissue, and it will help support this kind of body of this kind of embryonic chordates, as well as some lower chordates. Then we know that the vertebral column, yes, is flexible, extending from the neck all the way to the caudal region, made up of bones, and of course in between them we have some cartilages. So this is simply something small that we have to know about the notochord. Okay, so I believe you find it helpful. Please share with friends so that they also understand these things we talk about. I'm very grateful for your time this evening. Have a good night, and may the good Lord richly bless you.